योगः कर्मसु कौशलम्.
Hello my dear learners, I am Shivam Zaveri, an assistant professor of mathematics in CUE department Gujarat University. Today we will learn one important topic of distribution theory, which is exponential distribution. So my dear learners, today we will understand the basic concept of exponential distribution, and then we will understand the serial, means cumulative distribution function of serial, and then we will solve the example of the exponential distribution. So my dear learners, before starting exponential distribution, we understand this thing that this is our practical paper, MAT 405 practical paper. In this session, we will discuss only practical sums rather than theory. Okay, so let's start with exponential distribution. So let's start. So first thing, introduction is the exponential distribution is continuous probability distribution, means we need PDF. Okay, so now that describes the time between successive events in a Poisson process where event occurs independently at a constant rate, average rate. Okay, it is widely used to model waiting times, means queuing model. It's useful in queuing model, such that the time until a machine fills the time between customer arrivals or the time between the phone calls at a call center. For example, we understand the exponential distribution like this way. Okay, this is our bank counter. This is our bank account. This is star. This is okay. This is our curly bracket. Okay. For example, this is a different types of sign we have. Okay. So let's understand that if the star is at a first number, okay, so star going to the counter, means this is a bank counter. Okay, so at star is reached at bank counter is around 1 hour 2 minutes, means this time period. Okay, and after getting a service, it will go back, means it will go back out, means go outside the bank around, means it will he or she will left the counter at around at 1 minute, 1 hour 5 minutes. Okay, so here the service time is around 3 minutes. Service time is around 3 minutes. So in this scenario, means waiting time, in this scenario we use the exponential distribution. Okay, so now if a random variable x represents the waiting on time until the next event, means until the next event, then x is said to follow an exponential distribution with parameter lambda 0. Okay, so here lambda is our parameter. For the exponential distribution, mean is 1 by lambda and variance is 1 by lambda square. Okay, so now understand the PDF. Okay, so probability density function. Okay, so if x follows exponential distribution with parameter lambda, this is our PDF. Okay, this is our PDF. Okay, so now, okay, so x follows exponential distribution with parameter lambda. Okay, so here lambda is greater than 0. Okay, so now mean is 1 by lambda, as we know that mean is 1 by lambda. Okay, so not mean, here is variance. Variance is 1 by lambda square. But what about the standard deviation? Standard deviation is under root variance, means 1 by lambda. So my dear students, we have to remember that in the exponential distribution, mean is equal to the standard deviation. Okay. So now let's understand the practical things. Okay. So before starting practical things, we have the one formula regarding CDF. Okay. So CDF, cumulative distribution function. Okay. So whenever we are processing the means we are calculating the exponential distribution, means probability of exponential distribution, we have the CDF, means we have the CDF. CDF means cumulative distribution function, means for example f of t less than d, means less than equal to d, e raised to minus, okay, e raised to minus d. Okay, so this is the thing. Okay, so now let me clarify everything. Okay, so this is the real t is this. Okay, so to find to solve this function, okay, to solve this function means probability, to find the probability of this function. Okay, this is our CDF. This is our CDF. Whenever we are saying this less than or equal to within, that time CDF is useful. Okay. So what about the more than that? Okay, when you see the more than, okay, when you see the more than, that time greater than 0 means e raised to minus lambda. Okay, so now the time between incoming call at a customer support center follows an exponential distribution with mean 5 minutes, means mean equal to 1 by lambda. So lambda equal to 1 by mean means 0.2 minutes. Okay, so find the probability that next call arrives within 3 minutes. Within means this type of. So we have to calculate probability within 3 minutes. 3 less than 3 means 1 minus e raised to minus lambda means 0.2 into 3 means 1 minus e raised to 0.6. Okay, so here e raised to minus 6 into e raised to minus 6 into minus 1 plus, so around 99.75, or you may say that you have to calculate that 1 minus e raised to minus 6, e raised to minus 0.6, sorry, 0.6 or 6, okay, sorry, it's e is 0.6, means minus 5488. Okay, when you subtract this particular thing, you get 0.4512. Okay, so this is the probability for within a 3 minutes. Okay, so now probability that waiting time is more than 4 minutes. So my dear students, we understand that more than 4 minutes means probability of t greater than 4. Okay, to find probability t greater than 4, we have e raised to minus lambda raised to t. So e raised to minus 0.2. So now, okay, so e raised to minus 0.8 is nothing but minus 4493. Okay, so probability that waiting time is between 2 and 6 minutes. So 2 and 6 minutes means greater than 2 and less than 6. So how can we do this thing? Okay, so now we can do by the separate form. Okay, so here 2 is less than, means we can say that 2 is less than t and t is less than 6. Okay, so now, okay, to find 2 is less than 3 means for example I think we have this thing. Okay, a is less than b and b is less than c. Okay, so how can we find? So now we have to calculate there. So now we have to calculate the probability t less than 6 minus probability t less than 2. So how can we find t less than 6 is 1 minus e raised to minus 2 6 minus 1 minus e raised to. So now solve this bracket, you will get e raised to minus 0.4 minus e raised to 1.2. Okay, so in this way you can calculate this thing. Okay, so now what is the value of e raised to minus 4? Here e raised to minus 0.4 is nothing but 0.673. Okay, sorry, 03, my mistake, minus e raised to minus 1.2, so minus 0.301. So now solve this thing. Minus 6703. So his probability is 0.3691. Okay, so in this way we can do this thing, means calculate the probability also. So now understand that probability that waiting time, sorry, find the variance of the distribution. So how can we solve the variance? Variance is 1 upon lambda square, or you may say 1 upon lambda into 1 upon lambda, means 1 upon lambda is 5 and 5 is 25. Okay, or apart from this you can solve this also this method. 1 by lambda square is 1 by 0.2 square, which is nothing but 20. Okay, so in this way you can solve the variance also. So now let's understand the next question. Mean time is 200 hours. Okay, means 0. Okay, 005. Okay, we can also clarify this thing. Okay, so find the probability that components fail before 100 hours. Means we have to calculate t less than 100. Sorry. We have to calculate that before 100 hours, means t less than, means 1 minus e raised to lambda t. Lambda t means lambda is nothing but minus 0.0, sorry, minus lambda t. So e raised to minus 0.5. Okay, e raised to minus 0.5. So e raised to minus 0.5, which is nothing but 0.6065. Okay, so probability that at least more than means t greater than 2 is equal to minus. Okay, so e raised to minus 0.05 into 250 means 0.2865 minus 0.2865. So probability that the lifetime between 100 hours and 300 hours. So now 100 is less than 3 is less than 300 means we have to calculate P of less than 300 minus P of less than. So now e raised to minus lambda minus, or you may say that 1 minus, okay, so minus 1 plus e raised to into 100. So now e raised to 0.005 into 100 minus e raised to. So now e raised to minus 0 point into 100 means minus 0.6065 minus e raised to minus 0.05 into 300 0.2231. So now solve this terminology. 3 4 okay, 38. So here the probability that between, you may say that it's an interpretation that chances that the lifetime is between 100 and 300 hours. Okay, so now at last find the variance. Okay, so find the variance. So how can we find the variance? Variance is nothing but 1 by lambda square. 1 by lambda into lambda means 1 by lambda means mean. Mean is 200 hours. Okay, mean is 200 hours. So 200 into 200 means hours. Okay, you may say that remove this terminology. Okay, this is nothing but your variance. Okay, so now let's move to the example number 3. The waiting time for a bus at bus stop follows exponential distribution with mean. Mean equal to 1 by means mean equal to 10 minutes means lambda equal to 0.1. So probability that passenger waits less than 5 minutes means we have to calculate less than 5 means 1 minus e raised to minus lambda means 1 minus e raised to 0.5. Okay, so 1 minus e raised to 1 minus e raised to minus 0.5. So you can get the answer is 0.3935. Okay, so 0.3935. Okay, so now probability of waiting time is greater than 15 minutes. Greater than 15 minutes means 1 means e raised to minus lambda means e raised to minus 1.5. So how can we solve e raised to minus 1.5 means 0.2231. Okay, means 22.31% chances that the waiting time is greater than 15 minutes. Okay, so how can we find the between? Between means probability that 5 less than t less than 12 means probability is t less than 12 minus probability of t less than 5. Okay, so in this way you can solve this particular terminology. So find the variance. So how can we solve the variance? Okay, so variance is nothing but 1 by lambda square means 1 by lambda whole square. What is a 1 by lambda? 1 by lambda is okay 10 means 100. Okay, so in this way you can solve the example number 3 also. So my dear students, this is one practice example you can solve by yourself. Okay, so mean here I just give you hint. Mean equal to 1 by 8 means 1 0.125. Okay, within 4 hours means you have to calculate t less than 4. Okay, probability there works more than 10. More than 10 means greater than 10. Okay, probability that time between 5 is t less than 12 minus t less than 5, and find the variance. Variance is nothing but 1 by lambda square. Okay. So first thing within, okay, you have to calculate t less than something a. Okay, sorry, it's my error. Okay, t less than 4 works more than means greater than, and between this and this, and 1 by lambda square. Okay, so this is our whole sums. Okay, this is our we saw all the components like before, more than, between. Okay, so within. Okay, clear? Okay, so we saw everything regarding it. Okay, so within means less than or equal to, more than or greater than means greater than, between means this and this. Okay, so every components we showed in this session. So my dear friends, if you have any query and doubt regarding these particular topics regarding exponential distribution sum, please feel free to comment on this video. I will definitely help you, and I will definitely reach out to you to solve your all doubts as soon as possible. Thank you very much.